All right, so welcome everybody to the Resilience Hub here at COP27. Good morning, good day, depending on where you're joining us from. And my name is Nino Omabo. I work with Green Africa Youth Organization as a program officer. Today we are discussing designing for crisis and conflict, integrated urban responses for people and infrastructure in response to climate-induced risk. And I'll be doing this with
Maddie. Hello, I'm Madeline Crosby-Schaefer. I'm the lead of Silver Linings Youth Initiative. Silver Lining is partnering with GAIO, Green Africa Youth Organization, for this event. Hello and welcome. Today's session will be looking at climate risk from a broader lens of urban resilience. So what we really want to ask during this session is what role emerging climate technologies such as solar climate intervention could play in managing near-term climate risks in cities. So could these risks such as extreme drought, extreme flooding, which have the potential to cause conflict as well, climate-induced conflicts, could they be mitigated by these technologies? What role could they play? And how could they act as a tool in our fight to increase urban resilience? And also, what gaps are there in our knowledge of these technologies? That's also an important thing for us to consider. And also, how can we, explore these gaps with research, with climate justice at its heart? So, over to Nii to open with our first speakers.
Okay, so first we'll have two presentations from climate scientists who are researching on solar climate interventions. The first is a very world-renowned scientist who we are so happy to have expert in our session. And then we'll have a short question and answer, right? That will discuss a certain method of solar climate intervention and how it interacts with extreme weather events in our cities. And then we'll follow it up with a discussion with other speakers, incredible speakers indeed. And then there'll be an opportunity for us to ask our questions because we also want to really hear from you. And so we'll move on. Our first speaker, which is Jim. Jim is a professor and Scott Presidential Chair in the Environmental Science and Engineering at Colorado State University. He's a member of the Joint Scientific Committee of the World Climate Research Program, and previously worked as director of the National Center for Atmospheric Research and president of the American Geophysical Union Atmospheric Sciences Division. So indeed a very expert speaker. And so we'll invite Jim. Welcome, Jim.
Yes, good.
You have the floor.
Thank you very much, and good afternoon to everyone. Hopefully you can hear me okay. And thank you very much for that kind introduction. I'm very honored to participate in this panel discussion. And I'd like to thank both Silver Lining and the Green Africa Youth Organization for the invitation to do so. What I'm going to do very briefly today is describe the risks caused by climate change, including to people in urban areas. And then, as was said in the introduction, describe one possible response option, and that is intentionally reflecting a small amount of sunlight away from the planet to possibly minimize those risks. I don't know if my slides are up. Yes, if we could go ahead and go to the next slide. So a critical point is that the risks from climate change to human and environmental welfare is not only a problem of growing importance for the future, but it's a problem for today. This is a plot, you've probably seen a plot like this before, of changes in global average surface temperature from 1880 to 2021, where the temperatures for each year are plotted as changes or departures from the average temperature over some 30-year period, in this case, 1951 to 1980. And the key point is you can see the global average surface temperature has increased about 1.2 degrees Celsius over this period. And we know the cause, primarily from ever-increasing concentrations of greenhouse gases in the atmosphere, due primarily from fossil fuel use as well as changes in land use. Next slide, please. And for every fraction of a degree increase in global average temperature over the coming decades, the negative impacts and the damage done increases significantly. This image is from IPCC 2018 1.5 degree report, and it summarizes the impacts and the risks across a wide range of natural, managed, and human systems relative to increasing levels of global temperature, indicated by moving up the vertical axis, where the gray shading that extends horizontally across the plot indicates the amount of warming that had occurred by about a decade ago. So changes in the colors from yellow to red to purple indicate more severe impacts. And the key thing is that you can see, even with slight increases in temperature over the coming decades, that warming will increasingly have harmful effects on many systems. Next slide, please. And so indeed, even with the 1.2 degrees of warming that we have experienced to date, we are witnessing very significant, perhaps even some catastrophic impacts from record numbers of extreme weather and climate events. This includes things like unprecedented wildfires from Australia all the way through Siberia in terms of both intensity and extent, record droughts and record flooding, record heat waves, and other weather and climate extremes that are affecting all regions of the planet. Next slide, please. Indeed, many of the biggest impacts from climate warming come from more frequent and intense extreme events. And this is very nicely and simply illustrated in the schematic, which shows that if the distribution of a climate variable, in this case temperature, that is typical of today's climate, which is illustrated by the gray area under the curve in the middle of the plot, shifts just a bit to the right. In other words, it warms up a degree or two. What used to be extreme cold weather events either no longer occur or occur much less often, while there is much more very hot weather in addition to perhaps record-breaking heat events. And this is important because it's been estimated that even with about 1.5 degrees of warming, about 14 or 15% of the Earth's population will be exposed to severe heat waves at least once every 5 years. And if we increase to 2 degrees of warming, that number jumps to between 35 and 40%. Next slide, please. And we are already seeing evidence of more frequent extremely hot days, especially in urban areas around the world. This is just one of many time series that I could show. This is a plot from Tucson, Arizona, which is a modest-sized city of about 500,000 people in the southwest U.S. And there, the number of days in the year exceeding 40 degrees Celsius has increased by more than 20 days in only the past 40 or 50 years. Next slide, please. And of course, earlier this year, in March and April, we saw a very long-lasting heat wave affect many parts of India and Pakistan, with some daytime highs in Pakistan reaching almost 50 degrees Celsius. And it was especially devastating because the region was also experiencing a very significant drought. It's been estimated that climate change made this particular heat wave about 30 times more likely. And we are seeing many examples of such extreme events occurring across the globe. Next slide, please. So the climate crisis is here and we have to deal with it. And importantly, through our actions, we can still largely determine what the climate will look like by the end of the century. If we act quickly and decisively to reduce carbon emissions, we can avoid perhaps even more dangerous levels of warming by the end of the century. But even in that case, please note, because of things like the long lifetime of carbon dioxide in the atmosphere, plus the fact that the oceans have already warmed substantially and will remain warm for a very long time, the planet will continue to warm over the next several decades, even under more aggressive climate mitigation scenarios. Next slide, please. What this means is that the climate impacts and the risks that we are currently experiencing will continue and likely worsen in the coming decades. And it also means that so-called climate tipping points, major changes in the behavior of the climate system or even transitions to new climate states, are now more important for assessing future climate risks. Now, these so-called tipping points or climate transitions have both global and regional consequences. And examples include what you see here, the melting of Arctic permafrost, which has the potential to release tremendous amounts of greenhouse gases that have been locked away in the frozen soil for many thousands of years. Next slide, please. The loss of biodiversity and entire ecosystems, such as the collapse of coral reef systems due to ocean warming. And next slide. And the disintegration of parts of the Antarctic ice sheet, which have the potential, of course, to dramatically raise global sea levels. So importantly, next slide, growing climate change impacts will have disproportionate impacts on the most vulnerable communities around the globe, including people in urban areas. So it really brings us back to the importance of climate mitigation, which is the only true solution to climate change, reducing concentrations of greenhouse gases in the atmosphere. So next slide, please. So how are we doing? Well, the good news is that if global governments implement the climate policies they committed to as part of the Paris Agreement and in continuing discussions, we would be on track for warming maybe in the range of 2, 2.5, or 3 degrees by the end of the century. But these values are still far above the 1.5 degrees Celsius of warming that will avoid the worst impacts from climate change. And as you are also likely aware, and I'm sure it's being discussed this week, many countries are not meeting their pledges. So we are far off track from limiting the warming to well below 2 degrees Celsius. And this won't change unless we immediately turn pledges into actions. And of course, we're going to continue to experience warming over the coming decades. Next slide, please. So this has led to a growing need to explore additional response strategies. In addition to reducing emissions, if we begin to bend that emission curve downward, implement large-scale adaptation and carbon removal, so that we are considering additional response strategies such as solar climate intervention that could possibly lead to enhanced safety for human and natural systems by limiting the warming to some value, for instance, say 1.5 degrees, until greenhouse gas concentrations are reduced to safer levels in the atmosphere. Next slide, please. The idea behind solar climate intervention is that we could intentionally cool the planet by introducing additional aerosols into the atmosphere. Now, an aerosol is a very fine particle in the air, and we know that aerosols have a cooling effect directly by scattering sunlight in all directions so that some of that incoming sunlight is reflected back out to space, or indirectly by, for example, helping clouds become brighter and whiter, thus also reflecting more sunlight back to space. Next slide, please. And the two most promising ways to reflect sunlight include injecting aerosols high into the atmosphere in a region called the stratosphere, or by injecting them into the lower atmosphere in regions where low cloud decks are semi-permanent, such as off the west coast of many continents. The next slide, please. This later approach is referred to as marine cloud brightening. And the frequently mentioned analog to this approach is ship tracks, which are evident in this satellite photo, where the bright white cloudy streaks are clouds that form around the exhaust released by ships into the ocean air. With marine cloud brightening, of course, we would not be releasing exhaust of any kind, but rather spray a very fine mist of salt water into the clouds, which would brighten the clouds and thus produce a cooling effect, at least regionally. Next slide, please. Now, stratospheric aerosol injection is a bit different, where the idea here would be to put aerosols into the upper atmosphere, perhaps at an altitude of 20 or 25 kilometers. Aerosols at this altitude remain in the air for quite a long period of time, maybe up to 2 years. And this would also directly reflect a small amount of sunlight away from the planet. Here, the natural analog is volcanic eruptions, such as Mount Pinatubo in June of 1991. They cooled global temperatures by about 0.5 degree for 18 months or so. Next slide, which is next to last slide. So could we do this? And we test these ideas, next slide, please, in model simulations that show that we could indeed, I think it skipped the model and that's okay, but we can test these ideas in model simulations. There you go. And if you could start the movie. And what you'll be looking at in the left is a climate model simulation of the change in surface temperatures as greenhouse gases increase. And on the right, what would happen to those same temperatures if we were to do stratospheric aerosol injection. And what it shows is this could avert much of the warming that would otherwise occur as a result of increased greenhouse gas concentrations, although there's still a lot of natural variability in this system, so patches of blue and yellow. Final slide. So I'm going to conclude again. I really appreciate this opportunity to at least introduce this topic. I just want to point out that this is I think, a very important area of research. We need to understand what all of our options are to deal with the climate process. And so while there are many questions about solar climate intervention, there are increasing calls to do research. In the United States, there's been a National Academy report that encourages the U.S. to work internationally in collaboration with other nations to pursue a interdisciplinary and multidisciplinary research program on this. And final tap of the slide, also professional organizations, in this case, the American Meteorological Society, has also issued a statement urging the importance of research into this topic. So I will stop with that. And again, very much appreciate the opportunity to see everyone today. Thank you.
Thank you very much, Jim, for your presentation. That's a good introduction to our session. Well explained, SAI and its role in climate intervention. Now we move to Yu Chen. Yu Chen Gu received a master's degree in Earth Sciences from the University College London in 2022, and is currently assisting the research on solar radiation and modification at the University of Exeter. Her research interests include climate change-induced extreme precipitation, aridity, and drought, and visualizing the effects of climate intervention strategies. What Yu Chen will be doing is to do a presentation on the scientific research of technological interventions and response to risks of extreme flooding in Chinese cities. So welcome, Yu Chen. Please.
Hi, hello. Thanks very much for the invitation. I hope you hear me well.
Yes, loud and clear.
So I'll just do a brief introduction. As Jim has already introduced what the climate intervention strategies are, I will specifically look at what the climate intervention strategy, especially the SAI stratospheric aerosol injection, can do in Chinese cities and how they can help protect the cities which are experiencing high flooding risk. May I have the next slide of the PowerPoint, please? Next slide, please. So it is important to know what has happened in China recently. We all know that the climate change will increase the surface temperature, and a high surface temperature will cause a more intensified water cycle, which is also leading to the increasing in the frequency and the intensity of floods. If we look back into these 3 years, what happened in China is that the seasonal heavy rainfall has especially increased in summer and causing flooding along the Yangtze and Yellow River. They are the main streams in China. South and East China has been mostly impacted due to the flooding events. What I want to focus on today is what happened last year. One of the most severe flooding events happened on the 20th of July, Henan extreme urban flooding event, which has led to 398 people dead or missing. Next slide, please. So what have happened on that day? According to the meteorologist, the highly hourly rainfall hits 200 millimeters, and later on, the rainfall has accumulated to around 550 millimeters just within 24 hours. If we think of this number, it is very striking. And the meteorologists also have concluded the major causes. One of them is the Typhoon Impha, and the second one is the Western North Pacific subtropical high combined with the local topography. A lot of you may not know what Western North Pacific subtropic high is. So basically, it is just a key circulation system that can influence the summer weather climates in the East Asia. Each year during the flood season, the strength and the position of this high could determine the location of the rain belt. Next slide, please. Next slide, please. Yes. So in case a lot of you don't know where Zhengzhou and the Henan province is, they're just located to the south of the Beijing, the capital city. And we also have the very important Apple iPhones manufacturing hub. Next slide, please. In the next few slides, I will play some videos as well as photos. If you can play the video, please. Showing what the flooding has done to the city. If you may kindly play the video, please. Yeah, sure, that's fine. So basically the video was taken by The Guardian, showing how people are trying to row in boats and taking trucks to rescue people who are still trapped in the flooding after the flooding event. Next slide, please. So this is one of the main intersections in Zhengzhou. We can see that all the cars, they are trying to drive in the waters. Next slide, please. And this is one of the important incidents I want to discuss today. So the first one is happened in the Jingguang Road North Tunnel. We can see that there are a lot of cars are smashed after the flooding event. It is because when the flooding happened, when the extreme rainfall falls down to the tunnels, people are trapped within their cars, and they have to abandon their car and start running to escape, which is very terrifying. Next slide, please. And the second one is what I also want to discuss. It happened in Zhengzhou Metro Line 5. Some of you may know it happens because when the extreme precipitation comes, people were trapped. There are 500 people trapped in the station, as well as 12 people were dead. So it's a very tragic incident that happened. It is because they are still operating the train line after the sign of the warning. Next slide, please. And we can see that there are some photos presented by the local news media showing that people are trying to memorizing people who have been dead due to this incident. Next slide, please. So the impact of the extreme urban flooding is very striking. Also, the direct impact caused 398 people dead or missing. And we can also see significant power outages in essential facilities, that including hospital, which we know that it is very important for people in ICU to using all kinds of machines, and also it disrupts the transportation. The agricultural loss and economic loss are also very enormous. The economic loss can be reached to 9.2 billion USD. Next slide, please. So this is the second part of my talk. I want to present you to some results of my research on could the increase of the reflection of sunlight from the atmospheric reduce the severe climate impacts and extreme precipitation in China. Next slide, please. As Jim has already mentioned a little bit on what the stratospheric aerosol injection is, I will just do a brief reintroduction on it. It is basically a very popular sun dimming technologies. They are trying to increase the reflection of sunlight by introducing sulfate aerosols into the stratosphere. The reflective particles can reflect sunlight into the space and cool the earth. The basic principle is to mimic a natural volcanic eruption based on the cooling evidence from the 1991 Mount Pinatubo eruption. And the use of SAI will also influence the hydrological cycle. Next slide, please. So this is basically what we are doing our current research on. I was working with a lot of researchers from the University of Exeter. We're trying to assess the effect of using SAI to mitigate extreme precipitation in China. So this one is still not published yet, but I do encourage you to look up after we have published the paper if you are really interested. Next slide, please. In order for understanding, I have divided China into 7 subregions. For Beijing, the capital city, they are located in the North China. And for Shanghai, the very important economic center, it's located in the East China. Next slide, please. I want to especially focus on the Southern China. One of the major reasons is that they hold the most of the population, and the domestic as well as international business thrive in this area. They also are the main agricultural province, and they have the abundant resources as well as energy. Next slide, please. What we have used in our research is to use climate modeling to simulate effects of using SAI to limit temperature rise from the high greenhouse gas emission scenario to a medium scenario, which I've highlighted in the right-hand side on this graph. We can see that the use of SAI can help reduce a temperature of 2 to 2.5 degrees Celsius. Next slide, please. So, based on all the results I've produced, I especially picked the maximum one-day precipitation to show you today how the SAI and climate change can do to a country. It is because a high value in this index could indicate a very high chance of flooding. So in the left-hand side, I presented 4 graphs in here. The top 2 graphs are presenting the medium and high GHG emission scenarios versus the present date, which we can see that on the east half of China, all the maximum one-day precipitation is likely to increase under the influence of climate change. While in the bottom 2 graph, we can see that I've also compared a medium and high scenario versus the use of SAI. While we can see that SAI is very effective in reducing extreme rainfall across east of China, especially along the Yangtze and Yellow River, both under the high greenhouse gas emission scenario as well as the medium one. So the mitigation can cover really important cities. Next slide, please. These will lead to a discussion on the benefits of using SAI in flood mitigation. The first and the most important one is definitely that it can reduce potential flooding risk as well as extreme rainfall events for cities that are very vulnerable. And also it can allow governments more time to improve urban resilience through city infrastructure. For example, what happened in Zhengzhou Metro Line 5, because when they are designing the subway station, they do not consider what kind of amount of water may just rush in the station, and they do not have enough backup electricity storage. Next slide, please. However, we do have to consider a lot of other things, for example, the climate modeling on predictions as well as uncertainties, and we also need future research. Maybe we can collaborate with other scientists. And we also do have to consider to what extent we should use SAI as a choice and how long we should use it. Next slide, please. Yes, and that is the end of my talk. Thank you very much, and thank you very much for the invitation. I hope you enjoyed this short presentation from me.
Hello, amazing. Thank you so much, Yu-Chen, for your presentation. And now we turn to some questions. So I'll go to Jim now. And first of all, to find out from you, Jim, it's interesting to see your presentation on aerosol injection. And I'm just curious, how much aerosol injection do you think we need for some of the challenges that we see in Yu-Chen's presentation? And are we able to track to say, I mean, this is the amount of aerosol injection we need to be able to mitigate these effects?
Yeah, thank you very much. And that's a very good question. And in both these presentations today, you've heard a reference to Mount Pinatubo as a natural analog. You know, one of the things to communicate, I think, is that volcanic eruptions are, of course, episodic. And when we think about the potential of deploying stratospheric aerosol injection, that would be a deployment where these aerosols would be injected more continuously into the upper atmosphere. Your question about the amount of material that we might inject into the stratosphere would very much depend on a couple of different things. How much we wanted to cool the planet down. Do we want to cool the planet down? Do we want to stabilize temperatures where they are? And then also, as you go forward in time, what else is changing in the climate system? For instance, what greenhouse gas emission scenario are you considering? Would the world actually be following? The more greenhouse gases you put into the atmosphere, if you wanted to keep the temperature stable at some level, you would have to insert more and more aerosols over time. It's been estimated that with Mount Pinatubo, there was about 15 teragrams of sulfur dioxide injected into the atmosphere. As I mentioned, that cooled the planet down by about half a degree or so. So if you continuously injected something like 15 teragrams of sulfur dioxide per year, it's been estimated that would cool global mean temperatures down by a full degree. But again, it very much depends what the target is you want to reach and how the background greenhouse gases are changing in the atmosphere.
Amazing, thank you. I think that my next question will be how this could potentially affect the global south, because there's been research, perhaps, and different studies that have shown how SHI could possibly mean that we are going to shift the challenges to the countries living in the global south. So, an even injection. Do you see this as a risk, and how is it possible for us to mitigate these challenges?
Is this a question to me again?
Yes, if you can attempt, because it's something that I'm interested in knowing. Yeah,
so engaging the global south in these dialogues is incredibly important. It's more than important. It's mandatory. It's absolutely necessary to do this. When we think about how we might go about deploying this, having that sort of global equity to make sure that anything we were to do did not, or at least any sort of negative impacts or risks that could be introduced by doing something like stratospheric aerosol is minimized, and that there's, the overall net effects of doing this would be positive for all regions of the globe. We have a pretty good understanding that if we reflect more sunlight away from the planet, that we can indeed cool the temperatures down. Many of the open research questions, however, are what, as in Yu-Chen's presentation, what would happen to precipitation in various parts of the world? How might the atmospheric circulation change? What are the detailed impacts on things like terrestrial ecosystems? And I think it's also important to note that again, stratospheric aerosol injection is not a solution to climate change. If we continue to increase greenhouse gas concentrations, other negative impacts from climate change, such as ocean acidification, would continue. So, it is an option we need to consider, but in considering that option, having truly global conversations around it and research to really quantify what the risks and what the benefits of stratospheric aerosol injection is relative to the risks of climate change is important to really have with a global community of scientists, including the global south.
All right, thank you so much. I think now we'll move to the next speakers. And so, Madi will introduce.
Yeah, thank you so much, Jim, for joining us. Really grateful for that informative talk and those answers as well, for clarifying those really, really key questions. Yu-Chen, we're going to keep you up. And with that, I'd like to introduce our following panelists for a broader discussion to really engage perspectives beyond China, beyond the United States. So with that, I'd like to introduce Kelvin Sa. He's been patiently waiting on the screen there for those of you in the room can see him there. So Kelvin Sa, he's a Ghanaian geomatic engineer and also a youth leader. He's currently interning with the African Development Bank. He is the team lead of Delsa Engineering, a Ghanaian-based tech startup that specializes in using modern survey and digital technology tools like drones, satellite imagery, GIS, for things like environmental assessments and sustainable development projects and climate action, of course. And our other speaker joining us for the panel is Kelly Wanzer. Could we also have Yu-Chen up on the screen? It's Yu-Chen and Kelvin. Thank you. This is the executive director of Silver Lining, so the organization that I am working for with the Youth Initiative. She's an incredible leader in this space. She oversees the organization's efforts to promote research and policy, science-based policy, with an emphasis on that, and effective international cooperation on solar climate intervention and other rapid responses to climate change. So in that capacity, she has helped to develop legislation. She has testified before US Congress. She has served as a reviewer for the IPCC, the White House's National Science and Technology Council, and NOAA. You might have heard Nancy Pelosi talk about NOAA just there. It's a world-leading academic, research institution into climate. And she has also launched a research fund. But prior to founding Silver Lining, Kelly, she co-founded and serves as a senior advisor to the University of Washington's Marine Cloud Brightening Project. It's one of the world's leading research programs on marine cloud brightening. So that's a type of solar climate intervention that Jim and Yuchen covered briefly in their presentations. And that research basically wants to understand the cooling effects of particles on clouds. But today we're concentrating more on stratospheric aerosol injection. So thank you, Kelly. Thank you, Kelvin and Yuchen. Are they still going to be able to be with us? Tech team? Have we lost Kelly and Yuchen? Sorry, Yuchen and Kelvin?
No, I'm here.
You can hear?
Yeah.
As long as you're there. Ah, fantastic. Okay. Cool. So can we have Yuchen and Kelvin pinned? Is that possible? Okay. Well, we'll get started with the first questions. So to open this Q&A, I want to go first to Kelvin. So we have hopefully the maps, the PowerPoint presentation of maps I sent to you guys. Are we able to get those up? So while the tech team work on getting those maps up, Kelvin, I do want to ask, so you're a scientist, you're an engineer, and you work on flooding issues in urban environments in Ghana. So can you tell us more about your work and how you work on flood mitigation in your home country?
Okay. Hello, everyone, and thank you so much. I'm so pleased to be here. So in Ghana, actually, we have been using digital technologies. And when I say we, I'm referring to my startup, Delsa Engineering. There are other emerging startups as well that also use such technologies. We use remote sensing technologies like drones and GPS, satellite images. So one recent project, which is just displayed, is the Now Winning project, which we did in 2020, 2021, where we tried to create a flood resilience community. That was a community that experienced about over 1,000 millimeters of rainfall a year, and they had a lot of flood issues. So what we did was we used our drones and satellite images to fly and plan over the area. We created an auto mosaic map, which is what is displayed here, showing a general overview of the map. The next slide, please. So after we created this, we did what we call the flood hazard layer, where we tried to use parameters from existing flood data and data gotten from the meteorological agencies, the type of drainages, the existing levels of rainfall that is normally experienced there, the type of buildings, the elevations of the land, the highlands, the lowlands. So we create what is called a digital elevation model. So using all this, we try to model and simulate a flood in the area in certain specific and more customized softwares. And out of that, we generate a flood zone where you see in the blue areas, which are the edges, those are high land areas, which are less prone to flood. The medium areas are the yellow zones, and the red are very high zones. So what we did for the community was to create this layer such that whenever there's a flood, those blue areas can be safe havens where people can be moved or evacuated easily, whereas preparations were being made. The next one, please. As part of the assessment, we also did an impact assessment on buildings, where we tried to simulate the flood and try to point out how many buildings will be affected, what will be the level of effect, and which buildings are not affected. So this was done to support the urban planners, the disaster management organization, in terms of preparing for resilience and mitigation purposes, so as to know the people that have to be better compensated, people that have to be prepared, and the community, the kind of plans that can be inculcated in the design of settlement in the area. The next one, please. We also did one on roads, where we use the runoff level of rain whenever when rain falls in the area. We also use the size of the drains and the level of rainfall that is accumulated, whether those drains can or cannot. So based on this, we use a lot of data from the meteorological centers to try and test if the rainfall pattern is increasing, which means you have more rainfall, the drainage that is already existing over the years cannot be able to contain this new increasing rainfall as a result of climate change. So this also informs the communities on how to plan if there have to be road extensions, if certain roads have to be avoided during rainy seasons and whatnot. So these are some of the projects we work in Ghana, and we are looking forward to partner with more organizations to try and create the awareness and build more resilient communities.
Thank you, Kelvin. Thank you. And can we bring Yuchen back up to be alongside him, please? So, okay, given that experience, given that knowledge, what are your initial reflections on what you've seen today, on those presentations, on stratospheric aerosol injection, on these possibilities to mitigate urban extremes like flooding in China, as Yuchen investigated?
Yes, so I think when it comes to the aspect of geoengineering, that's releasing of these aerosols into the atmosphere to try and cool the environment, it's a very good idea, it's a good principle. I feel it's something that could be further investigated and put into action. But one issue that always comes up with that is the fact that people who are always against the climate fight and always want to make a case for release of emissions as a result of gaining profit, capitalize on this to say that if this is going to succeed in the long run, they're not going to want to reduce emissions. So what I feel is certain key things must be tested. The institutional readiness to implement this, the cost of it, and the sustainability, because it must be very, very cost intensive, and it also has to be sustained. But we realize that in the global north, for instance, where we have China and the US and UK and other places where there's a lot of funding, there's a lot of support, there's a lot of scientists and equipment to be able to bring this to being, it's more feasible. But when you come down to the global south, the institutional readiness in terms of sensitization of people, the community's readiness to accept that is one thing that could also be looked into in terms of even the equipment to research and try and put this into practice. So I would say it's a long way to go, but it's still very possible if we give it more time and more research and work.
Yeah, absolutely. Thank you, Kelvin. I just wanted to ask if, Kelly, Yuchen, do you have a response to Kelvin there? Concerns about, how can we make sure that places like Ghana have equal footing in the research? How can they participate? Kelly or Yuchen, feel free. Kelly? Yeah, let's do that.
Thank you, Maddie. Thank you for having me here, and really honored to be on this panel with these experts as well. I think that Kelvin's question, brought forward, and the theme of this session itself, which is how do we get the peer experts in other parts of the world put in a position to look closely at these proposals. And so if you have people like Yuchen on the sort of modeling and sophisticated end of climate science, and people like Kelvin who are experts on the ground in looking at these risks, then how do we get them at the table, and how do we get them equipped technically and scientifically to look at what might have to come partly from the global north in terms of some of the heavy technology, high performance computing, stratospheric aircraft to study and measure how the stratosphere works, but then really empowering local experts. As we can see, like, the local expertise is there if you have the resources and technology to work with it. So one of the things we do in my organization is we're really trying to highlight, how do we get more resources for expert researchers and technologists in vulnerable countries that they can look at these problems on a more equal footing. And so this conversation, thank you, Nii and Maddie, for putting it together, because these are the conversations we like to have, and these are the kinds of experts that we want to bring into the room in these fora. So it was a great question. It was a great answer, Kelvin. Thank you.
I'd just like to highlight there, actually, Yu-Chen, you moved to the UK to study. So that just kind of gives a sort of indication of, you know, where are the resources being piled into currently to study these sorts of things. So that needs to change. That geographical distribution of that research needs to change in that investment. So yeah. Oh, go for it. Please, Kelly. Kelly has a question for you, Kelvin.
Okay.
So Kelvin, your maps are very striking in terms of, like, this is current conditions in Ghana with respect to these red flood risk areas. And then do you guys also do forward projections, and what does that look like? And the community that you showed us in the map, how well equipped are they to adapt? Because that's a lot of homes and a lot of roads.
Yes, so actually in terms of adaptation, I would say there's a little slow boat in that area. We're able to do all this data collection, data analysis, and even future projections. So what we do something called change detection analysis. So we can do this flood risk assessment for some time, maybe 2020. We do a projection for 2025. So for the projections, we model it using the average rise in rainfall, the average flooding statistics being gathered, and over the years try and model to tell in 5 years' time, if this drain remains the same, the number of buildings affected will increase from 200 to 250. So what it means is that now the National Disaster Organization, in partnership with the local authorities, have to now take this data into consideration in expanding and building the settlement. However, the problem is that in this case, they do not really have such support. So when we do this analysis, we do this data collection, there's always a limitation of there's no fund. So we know what we are supposed to do, but we cannot prepare ourselves for the future. And so yet when it rains heavily, we still get flooded, and then we are not moving forward. So it's a little bit of a difficulty, but we are able to do flood simulations and projections. The tech ability is there, the ideas are there, the willingness is there. The only problem is the implementation support that mostly people struggle with.
Thank you, Kelvin. Do you have a response, Kelly, or should we move on to the next question? Okay. By the way, if the audience has any questions whatsoever, please do go ahead. Stick your hand up, or equally on the online chat. Yeah, we've got one there. Yeah, I can get you the mic.
Hi. Yeah. My question is around solar intervention and how you would attribute any changes in rainfall, or even a particular flood event, to climate change, greenhouse gas emissions, caused by greenhouse gas emissions, or could it be due to the solar intervention? So there's an increasing science of attribution for climate change. So would that also have to be developed for attributing events to solar intervention? And you know, could you trace the impacts of solar intervention?
Thank you. Thank you for your question. Kelly, you have an answer to that? Or Yu-Chen, we've got our own climate scientist.
I answered the question. Yeah. So for the impact of the solar intervention strategies, we are currently investigating. And I do understand that a lot of people are worried about, like, as I said already, the solar intervention strategies, they are going to influence the hydrological cycle. And a lot of people, they are trying to understand whether the extreme rainfall can be further lead to the solar intervention strategies. I can say that based on my research, I used to research on global scale of how the SAI can influence on the local both aridity and drought, as well as the extreme precipitation scenarios. I can say that based on my research, the extreme rainfall will not be further lead by the solar intervention strategies. But we do need more modal improvements, as I've mentioned, that we can improve on the regional variability as well as the natural variability, because as Jim has already mentioned, that the carbon emission that has already in the atmosphere cannot be mitigated just in a few seconds. So we do have to improve more on the modeling technologies, as well as what we can do to maybe have an experiment to assessing what exactly can be happen if we inject the aerosols into the stratosphere. Thank you.
Thank you, Yu-Chen. Kelly, do you have a follow-up response as well? Yeah.
Yeah, I just wanted to say it's a really great question, because the research like Yu-Chen and Jim do is, it draws out the uncertainties we have. The attribution problem is the same for solar climate intervention as it is for greenhouse gases, more or less, and it's a hard problem. And so I think what the researchers that we've gotten to know are just really interested in looking at those questions really closely, because you're only interested in solar climate intervention if it looks like it produces a safer condition with respect to these types of issues than your best trajectory for mitigation. And so, I guess for us, it's really terrific to see research like Yu-Chen is doing, and Jim too, to really drill into those questions hard and very openly, very collaboratively across countries, and out in dialogue to see what people think.
Thank you, Kelly. I hope that answers your question sufficiently. Awesome. Okay, thank you. Can I just check how much time we have left, as I believe it's past the hour? Um, 5 minutes? Okay, thank you very much. Thank you. So, all right, so I think just to wrap up the session, I wanted to ask the three of you, what can our audience members online and present in the room, what can they do to increase action on this subject? How can we go about taking personal steps to improve our knowledge, improve the dialogue? I'll start with Kelly because she's in the room, and then I'll go to Yu-Chen and Kelvin.
Thank you. It's a great question, and this is a really great discussion. Thanks very much. For me, what I hope people in the community here at COP and people watching online might think about who are in a position to help is, how do we build capacity for people like Yu-Chen and Kelvin to work not only on climate intervention, but actual climate impacts and climate prediction types of problems. What we've found in our work in Silver Lining is that there's a general deficit in research funding and technology access in the Global South, and particularly in the most vulnerable parts of the world. And so for those in the climate community who could help bring resources at the state level, at the philanthropic level, so that we can have more of this kind of work happening in all different parts of the world, that would be really valuable.
Thank you, Kelly. And Yu-Chen, what would be your message?
So for me, I'm kind of junior in this field, so I would really hope that people can get interested in examining flood or extreme precipitation. No matter how old you are, like no matter the age or experience, it is really important for people like you act as a citizens to interested in flooding, and you are focusing on what kind of flooding risk you might met. And a lot of city planning as well as infrastructures, they might not be as strong as you think. And I do hope that people can pay a little bit attention to their city's infrastructure. And if you find something you don't think that they might not be strong enough to combat the flooding risks, do report them and do tell people that you think there might be a problem. And also, I'm not sure who are watching this and who are presenting, but it is important to encourage people all over the world to get interest in this subject. For example, like Kelvin has said, maybe there are not enough researchers in Ghana to focusing on the local flooding risk. And I feel like it is really important to attract the people who are still young to start getting interested in this subject. Thank you.
Thank you, Yu-Chen. He's offline. Oh no. Okay, well, we'll have Kelvin's message in spirit through what he's shared throughout the event today. Well, I think that's all we have time for. Thank you so much to our panelists. Thank you, Nhi, and thank you guys for being here. If you guys want to continue the dialogue in any way, please feel free to reach out. Silver Lining, Green Africa Youth Organization, we're here to kind of facilitate that dialogue on these really key questions about these emerging technologies, and we don't want to leave anyone behind in that conversation. So thank you so much for joining us. And yeah, have a great rest of your COP. Thank you.